Today we're going to practice SQL with our good friends over at LearnSQL.com who are kindly supporting the channel by sponsoring today's video. The idea is very simple. They've given me unlimited access to the over 70 SQL courses on their platform, and I'm going to pick out a few questions from both basic and advanced level courses for us to solve together. And there's currently a really great deal on offer from LearnSQL.com that I'll tell you about a little later, so make sure you stick around for that. Okay, let's jump in. Let's start with the SQL Basics course. So we've got 129 interactive exercises, 10 hours estimated time, and over 322,000 users enrolled. So what have we got? Table of contents, a little bit on databases, selecting from one table, querying more than one table, aggregation and grouping, more on joins, subqueries, set operations, and a quiz. All right, let's start with something really easy, working with logical operators, in this case, OR. So we can see here the handy example that's been given. Select ID name from user, where age is greater than 50 or height is less than 185. So that's the example and the exercise we've got, and we're going to be working on this car database or this car table. Select the VINs of all cars which were produced before 2005 or whose price is below 10,000. Okay, so first thing is select VIN from car. If we run that, it's not going to be correct, obviously, it's not what's being asked for, but we can see what the result is. So that's great. So we're going to the where clause. The where clause is going to filter the rows that we want. So all cars produced, let's have a look at the database again. Production year is the name of the field. Production underscore year, where production underscore year is before, so less than 2005, or whose price is below 10,000, or price less than 10,000, like so. Let's run that, and there we go. We've got the correct VIN numbers for that. Sticking with logical operators, we've got the between operator, and the task here is to select VIN, brand and model of all cars which were produced between 1995 and 2005. Well, we're still working with the same data. So select, which one is it? VIN, brand, model from car. And let's run that. Again, obviously not going to be correct. We're going to need to put in the where clause to filter the rows. So where, it was production year, wasn't it? Production underscore year between 1995 and 2005. Let's run that. There we go. Another one successfully completed. Let's do a couple more before moving on to something a bit more advanced. So here we're going to be using the percent sign. The percent sign is like a wildcard, which basically means any characters coming, it can represent any characters. So we've got the example here, selects everything from user, where name like, and then it's a percent sign, which means that anything can come after the A, and that would still get picked up. So what we want is select VIN, brand and model of all cars whose brand begins with F. So select VIN, brand, model from car, where was it brand, like, and it's going to be F with the percent sign, meaning that it can, oh no, but it's not actually, it's not, because we've got Fiat there as well, and if we just used F and the percent sign, it's going to pick up Ford and Fiat. So we actually want to put the O in as well, which there's nothing else that has F that starts with the FO other than Ford. So if I run that, oh, wrong number of rows returned. Whose brand, oh no, it is whose brand begins with F. My mistake, I must have read that wrong. There we go. So Fords and Fiats are both included. This last one in the basic course is going to be using basic mathematical operators. So we've got the example here, which is select everything from user where the monthly salary multiplied by 12 is greater than 50,000. So you can see you can use multiplication, addition, subtraction, division when you're specifying your where clause. So that's what's the exercise? Select all columns, so select star for cars with a tax amount over 2,000. The tax amount for all cars is 20% of their price. So multiply the price by 0.2, i.e. 20%, to get the tax amount. Alright, so let's start with our select, and we want to select star from car, where. So we'll use the open parenthesis, and this is price times 0.2 is greater than 2,000, like so. Let's see if this is right. There you go. Fairly straightforward. All right, that's enough for the basic stuff. Let's move on to something a bit more complicated. Okay, now we're going to start joining data from two different tables. In our database here, we've got a table with movies, so movie ID, title, production year, and director ID. And then we have a director table with the ID, the name, and the birth year. So the exercise here is use the new construction join on to join rows from the table's movie and director in such a way that a movie is shown together with its director. Display all columns from both tables. Okay, in that case, we're going to do select star from movie, and then we're going to join director on. It's going to be movie dot what was it, director underscore ID equals director.id. Let's see if that works. And there we go. We now have all of the data joined together using the common joining key between the two data tables. Okay, this last one from the basic course is all about putting everything that we learned so far into practice. The exercise, we're still working with the movie and director tables. The exercise is to select the title and production year columns from the movie table and the name and birth year columns from the director table in such a way that a movie is shown together with its director. Okay, we've already done that, but we want to show the column birth year as born in and select only those movies which were filmed when the director was younger than 40, i.e. the difference between production year and birth year must be less than 40. Alright, let's start this by selecting the columns that we need. So it's title, comma, production underscore year, comma, name, comma, birth underscore year, as born underscore in. So from, and this is going to be movie, join director on, what was it, join director on director dot id equals movie dot director underscore id. Let's see if that works. Well, we've got the wrong number of rows, of course. We haven't added the where clause yet, but this looks good. We've got the title, production year, name, and born in. Maybe let's just have this as uppercase. Don't know why. Anyway, let's run that again. Okay, so now we want the where clause to filter the rows. Where, and what were we saying? Production year and birth year the difference between production year and birth year must be less than 40. So in parentheses, I'm going to say production underscore year minus birth year underscore year is less than 40. Let's see if that works. And there we go. It's just one. It's Pulp Fiction, 1994, Quentin Tarantino, who was born in 1963. So he was less than 40 when he directed that film. Now we're going to move on to an advanced SQL course. So what have we got? 3 interactive courses and an estimated time of 38 hours. So lots to get our teeth into. Let's dive in and look at some practice questions. Okay, so now we are going to be introduced to window functions. So what is a window function exactly? It's a function that performs calculations across a set of table rows. The rows are somehow related to the current row. For example, with window functions, you can compute sum of values in the current row, one before and one after, as in the picture here. Okay, we call it window functions precisely because the set of rows is called a window or a window frame. Take a look at the syntax. So, the window function can be an aggregate function that you already know, like count, average, sum, or another function such as a ranking or an analytical function that you'll get to know in this course. Okay, looking forward to that. The window frame is defined in the over clause. The large part of the course explains how to define the window frame with over. This is what we're going to talk about in the next exercise. Great, okay. Example, let's focus on over, which defines the window. The most basic example is over and parentheses with nothing in it, and means that the window consists of all rows in the query. So if we look at this query here, we've got first name, last name, salary, and average salary with the over clause. So average salary means we're looking for the average salary. Where exactly? Everywhere we can, because over with the open and close parentheses means for all rows in the query result. In other words, we're looking for the average salary in the entire company. Note that we did not group rows. Over makes it possible to show the details of single rows and the result of an aggregating function together, which wouldn't be easy with a group by. We'd need to write a subquery, which is more complicated and less effective. Over makes our work simple and efficient at the same time. Okay, so the exercise is, now let's turn your attention to write a window function. For each employee, find their first name, last name, salary, and the sum of all salaries in the company. Note that the last column is an aggregated column, even though you're not using a group by. Right, let's start by selecting our columns. So we want first underscore name, comma last underscore name, comma salary. And if we're going to be using this over function, we want the sum of salary, like so, over, remember, open and close parentheses means we're looking at all rows, so globally in the company. And this from, what's the table called? Employee, from employee. And let's see if that works. There we go. So what you can see here is the first name, the last name, and the salary of each employee, which is this column here. But using our over clause, we've actually managed to calculate the sum of all of the salaries in the company, and that result is present for every single row. So potentially now we could see what percentage this the salary for this person represented of the whole. Okay, you get the idea. So that's a bit more advanced. Let's see what else we can find. So this exercise actually goes further into the over clause and learning one construction, which is partition by. And that's what the syntax looks like. So partition by works in a similar way as group by. So it partitions the rows into groups based on the columns in the partition by clause. Unlike group by, partition by does not collapse rows. So let's see the example. They've put the example here already. Let's see the example. For each train, the query returns the ID, model, first class places. That's right, that's these here. And the sum of first class places from the same models of trains. So we've got our sum, first class places, over clause. And within the parentheses of the over clause, we have partition by model, okay, from train. So if we run this, let's see. So the database here, we've got, for example, Intercity 100. We've got 2 rows for that. First class places 30 and 70. So theoretically, if we are partitioning by model, for this particular model here, we should have a total of 70 as we are summing them up. So intercity 30 places, 40 places for this one, and a sum of 70 for both rows because they both contain the same model. You get the idea. So that's a good example of using the partition by in the over clause. Now we're going to partition by multiple columns. This is an example query here. So we've got the route ID, ticket price, sum price over partition by route ID and date. From ticket, join journey, blah, blah, blah. Okay, so in this one, we wanted to show each ticket with the sum of all tickets on the particular route on the particular date. Neither of the tables would suffice on its own, so we had to join them together to get all the columns. So yeah, that's understandable. The exercise that we need to do is show the ID of each journey, the date on which it took place, the model of the train that was used, the max speed of that train, and the highest max speed from all the trains that ever went on the same route on the same day. Right, I kind of get the idea for that. Let's do select, and the columns are, well, actually, let's look at the database. It's going to be journey, isn't it? So we've got the journey ID, we've got the date, and the model is in the train table. Right, so we're going to start off with this. We're going to start off with journey.id, journey.date, train.model from journey. Okay, and then we're going to join train on. So what's this going to be? Journey dot train underscore ID equals train dot ID. Let's see if that runs. Wrong number of columns. Of course it is. We haven't finished yet. We just wanted to make sure the first few columns are good. So what else do we need? We also want the max speed of that train and the highest max speed from all the trains that ever went on the same route on the same day. So I'd imagine train has a max speed. Okay, so we'll have train dot max underscore speed. And then we want let's throw a line there. We want the highest max speed, so that's the max aggregator. So the max train dot max underscore speed, and that's over partition by, and what are the ones we want? From all the trains that ever went on the same route on the same day. So journey will have a route ID partition by journey.route underscore ID, comma, and journey.date. Let's see if that works. Syntax error at near line 2, position the line, make corrections, and try again. Over max speed over partition by journey.route ID, journey.date from journey, join, should be okay. What have we got wrong here? Of course, we haven't got the comma here. Let's run that, and there we go. It's all correct. There's always a missing comma somewhere in my syntax. So that's the query result. We've got the ID, the date, the model, the max speed, and the max speed. We could alias this as well for all the trains that ever went on the same route on the same day. So a huge thank you to LearnSQL.com for sponsoring today's video and supporting the channel. It really does help us out and keeps the lights on. If you're interested in learning SQL, you really can't go wrong with LearnSQL.com. There are two different pricing options. Either you buy lifetime access to a single course for $39, or the All Forever plan gives you lifetime access to all 71 current courses and any future courses that get added. Normally it's priced at $5.99, but as you can see, there's a special mega offer on at the moment that gives you a whopping 73% off that plan, bringing the price down to $159. It is a limited time offer, as you can see, so make sure you don't miss out if you're serious about learning and becoming an expert in SQL. But that's not all. If you want to bag yourself an extra $20 off the All Forever plan, you can do so by joining and completing the Halloween Monster Hunt. It says, our company headquarters have been haunted by monsters. Use SQL to find the scariest one that took your promo code. Just hit the link in the description and use SQL to help us fight evil. Sounds like a lot of fun. If you enjoyed this video and want to see more SQL practice, do give it a thumbs up and turn on all notifications to make sure you don't miss any future SQL videos. Thanks for watching, and I'll see you soon. Bye.